In this video, we are going to talk about confidence interval and how we can use Python to calculate confidence interval for any data. So let's say we have small data and we are assuming that this particular data, so let's say this is like, these stars are the data points, and with these data points we can simply calculate the sample mean. And let's say we are getting this particular sample from a population that we do not know about, right? So we do not know about this particular population. Now in confidence interval, what we do, we try to estimate the population parameter with the help of sample. So let's say we do not know about the population mean, we do not know what it is, but we do know the value of the sample mean. Our goal is to find the population mean, right? Now what happens, the sample mean, since it has been randomly selected from this population, the sample mean won't be equal to the population mean, right? It will slightly deviate. It may be close to it, but it won't be exactly same as the population mean. We cannot say like, x is like sample mean equal to population mean. This is not true, okay, unless the sample size is really huge, but we are talking about small sample size. What happens, it will have certain degree of deviation from this population mean. It won't be the same. Now what happens, if you take another sample, let's say another sample, if you take another sample and if you take another sample, these all samples will have certain like sample means, okay, and these sample means won't be same as this one. So like there will be slight variation from the population mean. So let's say this line represents population mean mu, and if you are plotting this, then the sample mean will be somewhere here, another one will be here, another one will be, let's say, here, okay. So as you can see, it is slightly deviated from the population mean, okay. So it is slightly deviated. So let's say this is x1, x1 bar, x1 2, this is 3, and this is 4. So let's say these are our 4 sample means, and as we can see, this is the population, sorry, this belongs to this one. So this is the population mean and these are our sample means. So we are just simply plotting. As you can see, like there is certain deviation from the population mean, right? This deviation is nothing but it is called SEM. SEM means standard error of mean. This is nothing but standard deviation if you are plotting the graph of these means. So if you're plotting the graph and whatever standard error standard deviation you are getting, that will be this SEM, which comes out to be the population standard deviation divided by sample size. So this is the formula. But when you do not have the population standard deviation, because in this case we do not know anything about our population, we try to use sample standard deviation to find the value of SEM, okay. So our goal is to find the value of population mean within a range using confidence interval. So what confidence interval does, it gives you a range of value, so A and B, right? It gives you a value of A and B, and what this says that we are confident. Let's say we are 95% confident or 98% confident or 90% confident or 99% confident. We say that we are 95% confident that the population mean mu will lie between this value. So what this means, we are saying that our statistical procedure, whatever procedure we are carrying out, and we do that for a single sample in practice, but what we simply means that if we take multiple such samples and we start doing the experiment, we'll find that our population mean will lie for the 95% of the samples, whatever samples we have selected, our population mean will be contained within the 95% of the samples. That's what we mean. So it's kind of like we are finding a range, and if you are taking multiple samples, then 95% of the samples will contain the population mean. Now, since sample mean is slightly off from the population mean, what we do, we try to get a range of values. So this is the deviation here, which you can see in this is the deviation. But what we do, we try to multiply this with another value. So let's say this is value, so that we can scale this in both the directions. So if this is the line, we try to scale the value in both the direction in order to capture this particular population mean. So yeah, this is the population mean. We try to scale this in this direction. Let's try to understand with the help of a clean diagram. So let's say this is our population mean, which we do not know about, and let's say this is our sample mean. Let's just focus on a single sample. So let's say this x1. Now what we do, this is kind of like off SCM, standard error of the mean. This is slightly off, standard deviation from this particular sample population mean. What we do, we multiply this value with the with certain critical value, and what this does, this simply scales the SCM. It scales the SCM in a manner so that we try to just say that how far we need to extend this in order to cover the population value. So this particular value, how far we need to go in both the direction in order to capture the population mean. So this is what this is doing. So we are simply scaling the value. This is critical value. Critical value is simply scaling the SCM in both the direction, okay, so that we can get the value, we can capture the population parameter with the degree of confidence we have, okay. And let's say as sample is x1, then what we are going to do, we are going in positive direction, SCM into critical value, and then we'll also go in this direction, minus, in this direction we are going to plus. So x minus SCM into critical value. So we are going in both the direction. We are simply scaling in both the direction in order to capture the population parameter with a certain degree of confidence. Now how we calculate this critical value? This critical value is calculated from theoretical distribution. So whatever as a normal data distribution is, theoretical distribution is nothing but like some mathematical tools we use, and we assume that certain data follow certain kind of distribution. So if our sample size is less than 30, we say it is t distribution, and when a sample size is more than 30, we assume that it is a normal distribution, and we find the critical value from this normal distribution, okay. So from the normal distribution or from the t distribution, we find the critical value. So our critical value is nothing but a point, these points. So if you are considering two tail both the sides, then you want to find the critical value so that we can capture this 95% of the area on the graph, and we find the values here, okay, at both the ends, and this is called the critical value. So this is our 95%, let's say, confidence level of confidence level, and this area is nothing but this is like 2.5% this side, 2.5% this side. So these are like areas that are beyond our calculation. So these won't capture the rest 5%. So we are willing to make 5% error. So we use theoretical distribution to find the critical value, and then we multiply the critical value with the standard error of the mean, and we use the sample mean and plus minus this particular off value, okay. So this is how we calculate the confidence interval. So let's revise this once again, then we'll get back to the implementation part. So in our problem, what we have a sample mean or sample data, and with this we are trying to estimate the population mean. Our sample mean is slightly off from the population mean, plus minus slightly off. This off value is nothing but it is SEM into critical value. Okay, we subtract and add this critical value in order to capture the population parameter with certain degree of confidence. Okay, this SCM is calculated using the sample standard deviation if the population standard deviation is not known, and divided by the sample size. Okay, and this critical value is taken from the theoretical distribution we are assuming for our data. Theoretical distribution. So this can be t distribution and this can be normal distribution. So we have to, this critical value simply, what simply it does is simply scales the standard error of the mean. Standard error of the mean is nothing but standard deviation in the sampling distribution of the means. That means if you are taking multiple samples and making a distribution of them, then they will also have certain standard deviation. That standard deviation is called sampling error, standard error of the mean. Okay, and we use this critical value from the theoretical distribution we have assumed for our data. This theoretical distribution gives you a range, a critical value for the 95% confidence interval or 99% whatever area you are capturing. So from there we get the critical value. Now let's try to implement this whole thing, and we'll also explain one by one what is happening there. Okay, so that will give you an idea. Also note that when we say that SCM into critical value, that is called margin of the error. So if our population will be mean plus margin of the error. Okay, this is like of whatever off value we have, and then we have, let's say, this is plus minus, you can say. So this is margin of the error. This is nothing but SCM into critical value. So this is the simple formula we use. I want you to keep this thing in mind, that critical value is coming from theoretical distribution. SCM is coming from the standard deviation of the sampling distribution of the means. Okay, so these are like two different concepts. Don't get confused, because many people get confused from SCM and this critical value. Why do we multiply these two? We simply multiply because SCM is only giving us deviation in one direction, but we want to capture the population in both the directions. So critical value simply scales the mean in both the direction. Okay, so that when we subtract and add the value, we get this particular range. So this is what this critical value is doing. It's offering you how much you want to multiply SCM in order to capture the population with certain degree of confidence. Now let's try to implement this using Python, and we'll also explain the concepts. So you can open your code editor and you can start coding. So let's create a new file, conference.py. Okay, and make sure that you have some libraries installed, because we'll be using Numpy. Okay, and we'll be using Scipy to calculate the values. Okay, now the function is very simple. We have to simply find the mean, then we have to find SCM, then we have to find the critical value, and then we are going to plus and minus the value from the mean. So let's write the function. We are going to get the data, and we are going to get the confidence level. Confidence level is nothing but how much confident we want to be in our statistical procedure, in our calculation. So a user can input 95 or 98, 99. So and leave this to you to decide how you want to accept the input. You want to accept it in percentage, or you want to accept it in, like, decimals, or you want just the exact value. I'm expecting exact value like 95, 98. So it's up to you how you're going to expect the user to enter the value. Okay, now once we have our data and our confidence interval, what we can do, we can find the mean. Mean of the data. Once we have the mean, we can find the SCM. SCM is nothing but standard error of the mean. Since we do not know about the population standard deviation, we can simply use sample data, whatever data we have. So right now, the confidence level that we have received from the user, since I have received exact value 95, 98, what I'm going to do, I'm going to convert it into decimals. You can directly accept decimals as well, but I'm simply going to convert it into decimal value. Okay, here. Now once you have the confidence level, what you are going to do, you're going to find the cumulative probability for the distribution that we are selecting. So let's say we are selecting t distribution. Okay, so for the t distribution, or for any distribution, what we are going to do, we are going to find the cumulative probability. Cumulative probability is nothing but a function when the random variable is less than equal to certain certain value. So if you are starting from here and going to certain point, then cumulative probability is probability of this whole this value. Okay, so what is the probability that it will be less than equal to this value? So this is like starting from here to certain extent. Now if you want to find the cumulative probability, and if you want to get the value of critical value, what you need these 2 points. So you need these 2 points, because when you are saying 95%, you want to cover the 95% area on the graph, right? So you are capturing the 95% area on the graph. This means you are leaving 2.5% here, 2.5% here, right? So the value here will be 97.5%, and the value here is just 2.5. so if you can go either from this direction, you can find this particular value 97.5. okay, now how we can get this? One way to get this is, the total area under the curve is 1. We can simply subtract 2.5% and we can get this value, right? Now another way to get this value is 1 plus whatever confidence level we have, let's say 95, divided by 2. Now from where is this coming from? This is coming from 1 minus the whatever alpha value that you have. Okay, so if you have, let's say, 1 minus, so if you are taking this value, this simply means this is nothing but the alpha value that you are getting. Alpha is nothing but this 95% confidence is called 1 minus alpha, and this alpha is nothing but these two values. So this is the calculation of the value here. So you can simply select 2.5% alpha by 2, or you can simply find this value. So if you are going in both the if you are doing the calculation from both the ways, you will get the same value. And if you calculate this, you will get this particular formula, 1 plus 95 divided by 2. This means 1 plus confidence level divided by 2. So this will give you this particular critical value. And what we do, we find the z score, whatever distribution we have. If we have t distribution, we find t score. If we have z score, normal distribution, we find z score. So we are finding this particular point so that we can expect this value. Okay, and we can calculate the range. So we use this 1 plus 995 divided by 2. Now let's say we have t distribution. So for the t distribution, we also need degree of freedom, which is usually 1 n minus 1. And for the normal distribution, we only need the cumulative probability. Now one thing you need to do is you need to find the value. Since we already have the probability, we want to find the value. What would be the value? What would be the critical value, right? So when we have the value, let's say when we have the value, we find the probability which is given by cumulative function. But if you inverse this function, when you have the probability known and you want to find the value, this is called ppf. Ppf is nothing but percentage point function. It is inverse of cumulative probability function, whatever function that you have. So here we have value, we are finding probability, but here we have this ppf. That's why we are going to calculate cumulative probability first, and once we have the cumulative probability, we can use ppf. Ppf is the inverse of cumulative probability. It means that given the probability, we can find the value. So we are going to use cumulative probability, which is equal to 1 plus the confidence level divided by 2. So this is nothing but 1 minus confidence level, the alpha value divided by 2, okay, for both the sides. So once you have that, now one thing we forgot, that we also have to give the option to select the type of distribution. So you can also automatically select the distribution type. For example, if your length of the data is less than 30, then you can automatically select the distribution, or you can ask the user to decide what is the distribution they are expecting. Okay, so if they are expecting not t distribution, you should allow them to enter t distribution. If they want normal distribution, let them enter normal distribution. So I'm going to add another argument here. Okay, and once we have the argument, what we can do, we can create else statement, if distribution equal to t distribution. What we can do, we are going to use the ppf to find the critical value, which will be equal to stats dot t dot ppf. And also note that here we need the degree of freedom. So cumulative probability, and our degree of freedom will be nothing but length of the data minus 1. Okay, so let's see if so we have the length of the data. And now once we have done this calculation, we are going to add another condition for the normal distribution, right? We are expecting user to enter normal distribution, and once they have entered normal distribution, once we have this value, we can stats dot norm dot ppf cumulative probability. For this, we don't need this degree of freedom. Okay, so leave that. Now what we can do, in case user enters let's say they enter another value. Okay, so they are not going to type t distribution, normal distribution, unless they have the code. But if they are typing that, we can simply leave it, but still we need to take into account that condition as well. So we can simply raise the value error, and we can say that unsupported or not allowed. Okay, now we have our mean, our SCM, our critical value. What we can do now, we can find the margin of the error so that we can add and subtract that from the mean and get the range. Okay, so we have a critical value. We are going to scale the SCM. Then we are going to find the lower range, and this lower range will be nothing but mean minus margin of error. Okay, then we'll have upper range. It will be nothing but mean plus margin of error. Okay, now we can simply return these values, lower and upper. So this is like a simple function that allows you to calculate confidence interval, and we have gone through the entire procedure. First we calculated mean, then we calculated standard error of the mean from the sample data alone, since we do not know about the population standard deviation. Then we calculated this confidence level, I was expecting 95, 98, so I'll be converting that to decimal here. Then we calculated cumulative probability. Cumulative probability is nothing but going from one direction to a certain point, then we are finding the value. So what we are doing here, we are simply going to that confidence level, 1 plus the confidence level divided by 2. So this is like 1 minus confidence level divided by 2. So what this means, this is going to the right extreme point, and then it is finding the value. You can also use the lower extreme point, you will get the same result, so that is not an issue. I'm just doing this just to explain you that you can also follow the both the approaches. Once we have the cumulative probability, what we are doing, we are using the type of distribution. If we have the t distribution, we are using the PPF function for the t, and then we are using this degree of freedom, cumulative probability, and we are finding the critical value. Once we have the critical value, we are scaling the standard error of the mean, and we are finding the margin of error. Once we have the margin of error, we are subtracting to get the lower range, and then we are getting this upper range. So if you run this function, you will get the value. You can try to optimize this function for your own need. You can add some other conditions, like if the data length is less than 30, you can automatically select t distribution, and you can also adjust it according to your own needs. So this is like how you can find confidence interval in Python. So I hope this was helpful, and this is really simple. Instead of getting confused, simply try to find simply mean, standard error of the mean, and then find the critical value. Critical value is taken from the theoretical distribution. Now notice here that when calculating the critical value, we are not taking any data values into account. We are simply taking confidence level, and this degree of freedom is nothing but length of the data that we're taking just for the distribution purpose, but we are not actually using the data points, right? This means these values are taken from critical value. So this is something you have to keep in mind. This is not about the data distribution, this is about the theoretical distribution which we expect our data to follow. So when our sample size is less than 30, we expect our data to follow t distribution. When we have sample size more than 30, we expect our data to follow normal distribution. So this is how you can calculate this confidence interval. So this is very simple formula. That's it for this. I'll see you in the next video.